Coming live from the command center of the jwsolarusa USA in Minnesota. Thank you guys. It has been a while. I haven't made a video, approximately 3 weeks. And guys, this is what I'm doing here, trying to finish up the portable generator with the lithium-ion phosphate, the Panasonic lithium-ion phosphate, which are the 18650s, I suppose. I think so. I'm not okay. It's a lithium-ion phosphate. I suppose the 18650s. But look at the videos again. I just want to give you what I'm doing right here, trying to wind down or round up this one old project. And guys, this is what I'm doing. And the inverters here, you guys have seen the other portable generator, which is already done and it's ready to go. If you watch my last videos, you will see exactly what I'm talking about. And this is the first one ever we've started. So what I've done, I incorporated my bus bar that has both positive, negative buses here. And these ones were the ones that were on the batteries. This came from the this, I think it's a 6 gauge, a 6 or 2 gauge wire. Watch my videos back, it will tell you more detail. So this one is a negative that comes here. Then the batteries are built with BMS on them. Okay, they have a BMS battery management system, and I incorporated the positive goes to the input, which is the low. The input here, and this is the load side. So turn this wire and bring it and hook it up to the bus, and all the other equipment's gonna be here, hooking up here. So I put a 100 amp breaker here, which I'm running only a small inverter. You see that's a 100 amp. There you go. It's a thermal circuit breaker. So what it means, if it senses the heat, the temperature of that thing will just break the circuit right away. And this is up to 48 volts, I suppose. Is a waterproof. It's meant for outside, and when it breaks, it's all like this. If you push this button, it flaps. This lever will shoot all the way this way. So what I've done, I already put the batteries there. You guys have seen this cabinet before. I use it so that I can have little vents, but I use some kind of thick foam, whatever, for packaging or something. When I came with the batteries before, so the batteries down there can be flapping. If I have to move this box upside down or whatever it is, it's ready to go. So what I'm gonna be doing here, it shouldn't have been here. I was gonna put the inverter, the charge controller over here, because of the battery terminals are shorter that came from the bottom. So it feeds right here, and output is fed to the bus. Okay, so I want to utilize the ones on the back here so that the wires can be really neat. You can see the one that goes to the inverter, and this is the white that comes to the negative. So the charge control I'm trying to put right here. So by removing these guys, and I'm gonna get the charge controller, which is a kit by Midnight Solar. So I have a lot of the kits. I think I have 3 of the kits. Other ones I already put into different projects, and it's gonna sit right here. Doing so, though the transformer here is heavier, and that makes this side here becomes more heavier than this side here. It's on the side. It's gonna put it right here. I had to set up that way first, but because of the wires come from the batteries, it's shorter. And there's no other way. I'm trying to stay away from this guy. I don't want to cover up this guy, so the batteries can able to breathe. You can see the vent on the sides right here. I just want to pressurize so that this guy can be flipping a flap all the way, which are trying to get into the studs on the corner right there. You see a bolt right, not on the corner right there. So I gotta set up this guy right here and run the wires from the bottom right here. See those holes right there? And it's just gonna be shooting all the way to the bus bars. So that will give us a clean connection right here. It's a clean shot. So from here, hold on, from right here direct to the positive and the negative. and I'm gonna be bringing probably on the corner side here, give it a bust right here with the strain relief that comes from the solar that'll shoot all the way in here, and the battery ties to the bus. So now if we try to simulate something here by pushing this lever, that will power the inverter. That's going to be a light flashing right here. So I'm going to push the lever right here. There you go. You saw that flash? So now the power is already transmitted to the inverter, and it's not powered yet because I shut the thing down with the remote. But by pushing this guy right here, it started illuminating, flashing, and that means the inverter is already on. And that means here, see the power flashing right here is the breaker GFCI. That's the output, because this thing is designed to be tied into the breaker panel. So I just decided to do an extension here. If this wire, I can make this wire or this cable shorter, and maybe I can set it on the side here. See that? I can able to do that easily and get a clean setup right here. So every thing is gonna be by going through these guys right here, the holes, and switch it right away, and this guy's gonna attach right there, and everything's just gonna be really cool. Clean setup. I would think about it, maybe trimming this wire a little bit, make it shorter, and put the side there for plug and things so that I can have these wires hanging. And I have this is the charging that goes to the grid if we want to charge the batteries in case we don't have solar. So guys, what do you think? This is what I've done, and trying to complete this. These are the breakers here. It's the blue C, these are the numbers here if you're interested buying any of those. I've talked about this for a very long time if you look at my channel. And these are 50 amp, so I'm going to use that 50 amp here. Since this is a 30 amp breaker, it requires a 30 amp. It's a 30 amp MPPT charge controller, the PIP, but I'm going to utilize a 50 amp on it. All is going to be this way. I think it's going to be okay. Suppose I have a 40 amp somewhere, and I got all my tools here, but it's a 40 amp. I can able to use a 40 amp, but I want it to break when it's supposed to break. But I'm not worried about it. It's not a lot of panels going here. It's only for 12 volts. I think it's 500 watts, about 500 watts coming in here. So being said that, and this is gonna go the cap right here and set this guy, and we're gonna end up having a clean setup by protecting the buses, and it's gonna be a clean setup right here. Check this out. What you guys think? So, and these guys are not part of it. I'll take those ones out and get everything situated here, and we are ready to go for action. So I'm gonna be using the other breaker, or sorry, the MEARC50. I'm gonna tie with this one to control this guy so that we have a display panel. So it depends if I want to use it this side, because the remote is right here. So to do that temperature sensor, but we don't need a battery temperature sensor because these are lithium-ion batteries. They have battery temperature sensor in there. Disconnect them because you're gonna be having trouble charging. You don't need a battery temperature sensor on the lithium batteries unless if you wanted to. All right, but it's gonna restrict the charge. Anytime it sends that temperature, it's gonna be restricting the inverter. Or if you want to use a temperature sensor on the kit, it has a temperature sensor you can hook up to the battery or drop it inside the battery box. It senses the temperature in there. It slows down the charge, the rapid charge into the batteries. But I have to make sure I use this provision right here and get the thing right here, or I'm gonna able to utilize this guy on the bottom right here, okay, or the top right here. The remote's gonna be on the bottom. So either or I want to do is gonna be really cool. And got a battery boot, and everything is gonna be looking good. live from Minnesota, jwsolarusa USA. Thanks for watching. Love you guys all, and stay tuned, subscribe and share.